Hello, my name is Joel Chatfield, and welcome to Lab 4 Oscillations. Intro to key ideas. This lab we're going to be using Newton's second law of motion, momentum principle, along with forces in play are forces due to gravity and the spring force. Then there's going to be energy principle and energy and work. I apologize about the screen glitching out. It's something my laptop has been doing recently, and I don't know how to fix it. And it's 2 a.m., and I can't deal with this more right now. Formulas velocity update, position update, spring force, kinetic energy, gravitational potential energy, spring potential energy, and then all of that will be combined together to be the application of the energy principle. I apologize about the graininess as well, along with the screen glitching. My laptop crashed mid recording the other thing, the original version of this, and the sound got corrupted. So I had to take screenshots of this and put it back in to use it effectively. Um, this is all the equations we're going to use. It's the starting position for the vector, spring constant, and which I calculated, and then all of the gravity, all of the energy functions. And then along with that, we're going to have force due to gravity, spring force, total net, which is those two together, the position velocity update, um, the distance L of the spring, and then more energy updates, more energy update items. So these are the final things. You can see X and Y are Y. It's a slightly different range. Is likely due to imperfect tracking calculations. Then X and Y and then X ends up becoming slightly offset the further and further you go. That's because I use Y to calculate the spring constant. So that's probably some effect. And then this is the energy graphs here. This is the zoomed in energy graphs. Whereas you can see they all kinetic energy tends to go up and down as it moves back and forth depending on difference in velocity and all that. Um, and then red and green, as you can see, because spring and gravity are it's moving in a very controlled manner. We don't ever see it stop. They're about the same. And then the overall energy, because the energy principle, which we'll talk about next, stays the same. And then as you see, they're slightly offset. So X is slightly offset because we use Y to calculate spring constant. Is the energy principle satisfied? Yes, it is. As we saw beforehand, that orange line, that change in energy, stays right at zero the entire time. It doesn't change. It doesn't difference. So whatever energy is in the system is the energy that stayed in. It doesn't. It's not nothing leaving. And then what does it mean for the oscillations? So we have x and y data here, where I use to calculate x oscillations and y oscillations. And then effectively at the result at the end, we can do a calculation for t time, and then what k is in relation to t. You could likely do this more accurately if you did an average between them, or you did totally independent mappings, but that's hard to do. Thanks for lab. Like I said, I'm sorry. This is bad. This is at 2:30 a.m. and I'm dying right now.